Good afternoon, everyone. In this lecture series, we are going to discuss about the mesh analysis. Already in this previous video, we have discussed about the nodal analysis. In nodal analysis, we have seen how the voltages can be found out by using the nodes. The next one we are going to see about the mesh analysis. In mesh analysis, we are going to determine the mesh currents in an electrical network. So here the smallest possible closed loop in a circuit that contains no other loops inside it. So here we are going to consider only the two meshes, that is I1 and I2. So here the resistors has been connected and we are going to find out the closed loop in the circuit that should not be contains on the another loops. So that is termed to be as the mesh. In the nodal analysis, it is based on the Kirchhoff's current law. So here it is based on the Kirchhoff's voltage law. The algebraic sum of the voltages around any closed loop is 0. So here we are having the voltages, that is V1, V2, V3, another one will be the V4. So here we are going to take the sum of the voltages. The first one is the V1 voltage, the second one is V2 and V3, another one will be the V4. The sum of the voltages across the closed loop, it should be equal to 0. So this is based on the Kirchhoff's voltage law. The next one, we are going to see what are all the steps in the mesh analysis. We are going to identify all the meshes in the circuit and we are going to assign the mesh currents in the same directions. That is, we are having the current I1 and I2 and we are going to apply the KVL to each mesh. So this is the step we are going to analyze in the mesh analysis. The next, we know that already the Ohm's law, that is voltage is equal to IR, that is V is equal to IR. So we are forming the simultaneous equations and we are going to solve for the mesh currents and we are going to find the required branch currents or the voltages. So here the voltages, it is nothing but 10 volt. So here we are having the current, that is we are having the 10 and 40, that is it will be, we are considering the 50 and here the current flowing through this will be I1 and the next loop we are considering the I2. So here while we solve this equation, we will get minus 20 is equal to minus 40 I1 plus 60 I2. So we are using the formula V is equal to IR. The next one, we are going to see the current source in a single mesh. So the current equals the source current. No KVL equations is required for the mesh. So in nodal analysis only, it has been used, that is KCL has been used, but in this mesh we are using the KVL. The next one is the super mesh. So here we are going to see how the current source that has been obtained between the two meshes and we are forming the mesh excluding the current source and we are going to apply the KVL around the super mesh, that is Kirchhoff's voltage law. While coming to the advantages of the mesh analysis, it is very simple and it is systematic for the voltage source or the dominant circuits. Here there will be, the equations will be very minimum and the meshes or it is limited. So it is suited for the manual calculations. The next one, while coming to that of the limitation, it is applicable only to the planar circuits and it becomes complex with many meshes and it requires the extra care. While coming to that of the mind map, the first one we are going to see the basic principle. So in basic principle, what type of law it has been applied is, that is Kirchhoff's voltage law. And what are all the steps we have assigned means, we have to identify the loops. The next one, we have to assign the loop currents, we have to apply the KVL The next we have to write the equation, we have to solve the currents, and finally we have to calculate the voltages. While coming to that of the special elements, we are having the current source and the voltage source. Advantages, it is good for the voltage source. There will be equations will be fewer, and it is ideal for the planar circuits. So these are all the limitations of the analysis, that is mesh analysis. Thank you.